Welcome to On Topic, a series of conversations with experts on issues of importance to Alaska. I'm Jim Johnson, president of the University of Alaska, and this series of conversations with distinguished scholars and practitioners has been created in collaboration with the University of Alaska and the University of Alaska Press. We hear a lot about climate change and the massive swings in our weather patterns these days, so I'm happy to be talking to one of the foremost experts in the world on the subject to help us understand this and much more. John Walsh is the chief scientist at the International Arctic Research Center at the University of Alaska Fairbanks, and he's focused his long and distinguished academic career on Arctic climate weather variability. John was a convening lead author for the third U.S. National Climate Assessment, completed in 2014, and the author of many important articles, books, and reports on climate change, weather, and sea ice prediction. Before joining the University of Alaska, John spent 30 years on the faculty at the University of Illinois, Urbana, where he taught courses on weather and climate. So let me jump in with a question many people ask. What's the difference between climate and weather?
Well, the time frame is the main difference. But there are several interesting analogies. Climate is the long-term integrator of weather. Weather over a long time period does constitute your climate. But one of the nice analogies I've heard is that climate is like your wardrobe. Weather is like what you're wearing today. So we do have this difference in the time horizon, but when you piece the weather together over a long period of time, you get your climate. And it's not just your averages, it's the ranges as well. So you've been at this for over 30 years and have worked very, very hard, obviously, at this research and the teaching that you've done. Why this subject? What drives you, John, in terms of your focus on climate in particular? Well, climate and weather are both sciences in which you can apply the mathematics and the physics that you're exposed to at a young age in high school and college. And I find that those are powerful tools, but that the applied element is what's really appealing. I think science or physics for its own sake, math for its own sake certainly has a lot to be said for it, but when you can apply it to problems that benefit society and that are interesting in their own right, that there are things we experience from day to day, it really does make for a nice blend of experience and career. So why Alaska? You had a very distinguished career at another university. Why did you choose to come here? Well, I've researched Arctic weather and climate for 30 some years. And it's a lot different when you're close to ground zero, which we are in the Arctic. My previous work was down in Illinois, and you can always study a different region remotely. But it's not the same as being immersed in the environment. The connections to the Arctic research community are far stronger at a university like UAF than they are at a university in the lower 48. So the opportunities, both in terms of the immersion in the environment and the contacts, make UAF a very attractive place, one of the best choices in the world to do Arctic research. Well, you referred to the difference between basic research and applied research, and your focus has really been on the applied side. What are the applications of your research to the challenges we face today, particularly with respect to climate? With respect to climate, we are seeing changes in our environment, and those affect people. And again, Alaska is at the forefront in experiencing these changes. Our coastal communities, as well as some of the interior locations, are experiencing these changes firsthand. So we don't have to go far to see the impacts of what we're actually studying. And these changes appear as what we might call the slow or the creeping changes that evolve over time, as well as the more extreme events that can be singular events occurring over a day or two. Extreme storms, for example, or ice storms are examples of those. So those are the events that people are familiar with. We can certainly connect with the average person when it comes to the type of research we're doing, because people in this state and beyond are experiencing the impacts of what we're doing our research on.
So we're in a very polarized society, not just North Pole, South Pole, or living in an Arctic community, but socially, culturally, even politically. And a lot of that polarization is focused on this particular issue. How do you, as a scientist, someone who's committed to the scientific method and to empiricism, how do you see that polarization today?
No, the polarization is definitely there. It's emerged in the last decade or two. When I started back in the 1970s, climate change was a very uncontroversial subject. It was below the radar. There was certainly a lot less interest in it, a lot less awareness of it on the part of the public. But now it is mainstream news. I think I see our mission as to provide the factual information that people can use to make decisions. What we, in the long run, hope to achieve is an informed society when it comes to climate change issues. And just as an example, I came across a survey just the other day of people's beliefs on climate change and the factors that correlate with those beliefs. And what they found was that the people who are so-called believers in climate change, those who think that climate change is occurring and that it has a human-driven component, are the ones who are most knowledgeable on the scientific issues, just the basic, not just scientific issues in general, but the basic facts. Issues such as where's the North Pole? You might be surprised that more than half the people surveyed did not know that the North Pole is actually over an ocean. They thought it was on land. And there's actually a correlation between people's ability to identify or to sort out the facts with their beliefs on climate change, which I find is encouraging, because it implies that if we can contribute to a more informed public, we're going to have some more judicious decisions made, both at the individual level and at the aggregate level, higher up, where policy decisions are actually made. So I see that as the encouraging part of the issue. The discouraging part is that the strongest correlator with beliefs on climate change is political party. So I think we do have a challenge there that goes beyond the science itself. It's a societal issue and a political issue, and that's just something we have to reckon with and do the best we can to get the factual information out there and acted upon.
Well, I certainly appreciate hearing you talk about the critical mission that the University of Alaska and universities like ours, land-grant universities, play in not only discussions of science, but in discussions of policy. We have a critical role in that, and have since the 1860s, when land-grant universities were actually created. One of the great things I've seen about the University of Alaska in particular is the collaboration among faculty, not only within the sciences, because climate, you know this so much better than I do, it's not a one discipline field. Scientists come from different disciplines together to work and lend their own insights and discoveries to this field. How about working with social scientists? Is that something that you do at the International Arctic Research Center?
We do, and it's something that has evolved just in the last 5 or 10 years. We have a couple of centers within IARC. One of them is called the Alaska Center for Climate Assessment and Policy. It's funded by NOAA, but that's a blend of social scientists and physical scientists, and we come together on climate adaptation and climate adaptation planning. We've had several projects where we actually go to Alaska communities and develop climate adaptation plans. And those plans require a lot more than just the basic physical science information. They require that you identify the issues that matter to the community. And what's going on, and not just from climate. Climate is one of the stressors on a community. There are also political issues,
yes.
governmental issues, non-climate environmental issues, contaminants, for example. They all need to be worked into an integrated picture in order to develop a plan or a strategy for dealing with changes over the next 10, 20, or 30 years. And that integration really does require the interplay between climate scientists, social scientists, and other types of scientists. Ecologists, for example, play a major role in that because communities in Alaska are very ecologically oriented. They look at the system as a whole rather than individual components. So we've really benefited from the diversity of the faculty and the other activities that are ongoing here at the university.
Often I think of intellectuals and scientists being, in their offices or in their labs solo, working on an issue. And I assume that that's still a big part of the work. But what you're talking about here, John, is really collaborative. It's a team approach, it sounds like.
It is. It involves going out to the communities as well. So there's a team and a team immersion aspect to this, where we immerse ourselves in the communities, and that's actually fairly new in climate science. We've gotten out of the office before by going out into the field, making field measurements, going on cruises and that type of thing. That's more in the hardcore science realm. But this interaction with communities is what has really come to the fore just in the last 5 or 10 years, with the realization that climate change is ongoing here and it's impacting communities.
In the debate about climate and the extent to which humans are causing it and the extent to which it might be natural, is there something you can share about, is there a weight perhaps that science has been able to identify that's human caused, and then a portion of it that's natural? Because I suspect that both of those are involved.
Yeah, there are several dimensions to that. In terms of just changes in the global average temperature, which is probably the coarsest measure of climate, the consensus is that well over half of the change in global temperature over the last 50 to 100 years is human-driven. When we get down to the local scale, there's a much more complicated explanation, because natural variability, internal variability, does show itself. But there have been two particular events in Alaska that we've studied just from this viewpoint that you bring up. What's the relative importance of the human and the natural part of the driving? One of the events was what we call the Alaska marine heat wave a couple of years ago. In fact, this is still ongoing to some extent. It's the abnormal warmth of the water in the Bering Sea and the Gulf of Alaska. And that had impacts. There were major bird die-offs, seabird die-offs. There were toxins that were in the water. In fact, some cases of paralytic shell poisoning that resulted from the high water temperatures, and that's tied in with the absence of sea ice over the last couple of years. So we addressed the question of how likely that extreme event would have been without climate change. And the conclusion was that it could not have happened without climate change. It would not have happened back in the pre-industrial period. But by the same token, it did require a kick, so to speak, from natural variability.
I see.
So in a sense, an event like that was the perfect storm between climate change and natural variability. Some of the extreme fire seasons that we've had in Alaska also fall into that category. There have always been fire seasons in Alaska. It's part of the natural system. But the extreme burn years we've had since 2000, we've had 4 or 5 of them now, that collection would not have happened again without climate change. At least that concentration of extreme years in such a short period would not have happened without climate change. On the other hand, any individual year is shaped largely by internal variability. We've had some very quiet fire years, which is a reminder that there are ups and downs, even though you may be on a trajectory that's upward or downward in a particular variable. One of the analogies I like to draw is to the stock market. You can be in a bull market There's a clear trend with some implications, certainly for the economy and the investors. But on a day-to-day basis, there are ups and downs along the way. So you end up over time with, in a bull market, you end up with higher highs and higher lows. But it's certainly not a straight line path. So it's that merger of the underlying trend, which in the climate case is human-driven, and the natural variability that does give you these memorable extremes, whether you're talking about weather and climate or the stock market.
That I appreciate your raising that example and that comparison. And a question I wanted to ask you is forward-looking. We try to predict where the stock market is going, and there are very, very sophisticated models, quantitative models that attempt to do that. And similarly in your work, and you've been a real leader in modeling, quantitative modeling. What are some of your thoughts about modeling and looking forward? There's going to be a level of unpredictability there, but that's been a contested area of work, right? What are some of your thoughts about looking forward and modeling?
There's definitely uncertainty in these projections, and in fact, that limits the use of them. There's no getting around that. Many planners and decision makers want definitive information about what to expect in a particular time horizon. And these uncertainties are there for a number of reasons. One of them is that natural variability that we talked about. Even if there is a trajectory in the average climate, which we're virtually certain there is, there will still be these ups and downs superimposed. So you'll still get an occasional cold year, even in a warming climate. There was a period of 4 or 5 years back in the early part of this decade when even the global temperature leveled off. They call that a hiatus. But the warming has since resumed at a fairly rapid rate since then. But those interruptions are one of the contributions to the uncertainty. A second contribution to the uncertainty is that the models are not perfect. But we see that with weather prediction. There are models that show quite a bit of skill in weather prediction, but they're on a day-to-day basis, but they're occasionally wrong. And that's because the models are not perfect. They're formulated based on what we would call inadequate resolution. They're not resolving all the important features like individual clouds and things like that that ultimately contribute to the way weather goes. And then there's a third uncertainty in this future projection, which is the actions of people. Whether we get our act together and mitigate or not will have a lot to do with the climate 50 or 100 years from now. In fact, you can get a factor of 2 difference in the warming depending on which scenario of greenhouse gas emissions you assume. So we have a sort of a major uncertainty that's dependent on people and our own actions. That there's a plus side to that, which says that which is that if we do get our act together and seriously mitigate, we will make a difference in future climate. On the other hand, we cannot assume that that's going to happen. If it's a business as usual scenario, we'll be at the upper part of the range of projections. So we do have these uncertainties that are out there, and we need to make sure we convey those uncertainties to users or stakeholders, decision makers, without diminishing the utility of the information itself, the fact that there will be changes down the road. So there's a very delicate interplay between the use of the information and the uncertainty. And this is another area where social scientists come into the picture. How do you make decisions or plan with uncertainty in the future? And it's uncertainty that grows over time. So I think we have to reckon with that uncertainty. It's not going to go away. We may narrow the window of uncertainty a little bit by improving models, but again, that's only one of several factors that are contributing to the uncertainty. So we can say with very high confidence that on balance, the world is going to be a warmer place in 50 years. But if it comes down to a question of your backyard in a particular season of a particular year, there's a lot less confidence in just what the difference between then and now will be.
Well, clearly there are negative aspects of what we're calling climate change. There's no question about that. Do you see any, I'm not trying to be overly optimistic or anything at all, but are there any upsides from your view?
I think there are, especially for a region like Alaska. One of the more obvious ones is the reduction in heating costs, just because we're going to have warmer winter temperatures. We've already seen that to some extent. So there's at least one fairly quantifiable impact of a positive nature.
Right.
Another one, which is somewhat more tenuous, but it's certainly an interesting one, is the change in the growing season. Over most of Alaska, the growing season is increased by a week or two over the last 50 to 80 years. The data show that, and the climate models suggest that we may experience even greater increases between now and, say, 2100. We could see growing seasons that are a month or two longer. That opens up some possibilities. We aren't going to turn into the Corn Belt here, but there certainly could be some opportunities for agriculture that go beyond what we have right now. Then a third potential benefit, which in some respects is a mixed one, is the increased marine access that will occur over the western and northern seas around Alaska. Resupply operations will certainly be more feasible or more reliable in the warm season than they have been in the past. That does mean more ship traffic, which introduces other risks. It's sort of a mixed bag as far as community responses to that type of change goes, but there is a positive side, which is that the opportunity for marine transport will be greater than it has been. In fact, that raises a very interesting example that I like to point to. The pipeline in Alaska is now 50 years old, roughly. But back in and we accept it. I mean, it's part of our landscape. But back in the late 60s, when the oil was really discovered and the plans were being made for big time development, there were serious options given to transporting the oil by tanker out of the Prudhoe complex. And it came down to a choice between the pipeline and the marine transport route. The oil companies at the time sent a few experimental ships to test the waters, so to speak, or to test the ice, so to speak. And this was back in 1969 and 70. And they had enough trouble with some reinforced ships that they decided to go the pipeline route. Now, if that decision had come up today, 50 years later, there's a very good chance that we would see the transport, the marine tanker transport option get a lot more attention and perhaps some implementation. So I think that's an example of how climate change, at least over the time frame of half a century, can result in different options that can have some fairly big implications for a state like Alaska.
Well, that's a really interesting point. I hadn't thought about that. The implications include the Alaska Native Claims Settlement Act and the establishment of 9 out of the top 10 private for-profit companies based in Alaska. All came out of that choice. It's fascinating.
I mean, Alaska could be a very different place if the option the other option had been followed.
Yeah, very, very interesting. To what extent does your modeling of climate and the quantitative side in particular relate to or feed into work done by economists? You've talked a lot about the social scientists and political scientists and others you're working with, but some of the big issues around climate and how we adapt and mitigate long-term are economic issues. In fact, I think the recent Nobel laureate in economics is actually focusing on these issues. So I'm wondering your take on the economics of climate change.
It's really a developing interaction, the one between climate science and economics. And that there have been some initial estimates of just what climate change will mean in terms of dollars down the road. And there's a lot that goes on in the economic side there. They work in terms of carbon equivalence and what the dollar value of a carbon equivalent is and that type of thing. But the estimates do come out in the trillions of dollars for the consequences of climate change. Now, most of those consequences are in the lower latitudes, the middle latitudes, where the larger populations are, and most of them do relate to sea level rise. That's the big big elephant in the room when it comes to economic consequences of climate change. But there has been some work done here at the university, in the Institute of Arctic Biology, coming up with some estimates of what Arctic variables are contributing to the economic impacts of climate change. And it turns out that the loss of snow cover and the way it magnifies the warming of an externally driven climate change is a non-negligible factor. We also have the possibility of the additional carbon releases from the thawing permafrost, which is another Arctic contribution that's up there with the major players in terms of the contributing factors to the broader economic impacts. Because either way, if there is a large-scale warming, it may be driven in part by Arctic changes, but it's going to impact other parts of the world where the population and the infrastructure is much greater.
Yeah, I was just in New Orleans a couple of weeks ago and walking along a street and looking over and thinking, that river seems to be above the street level here. And so that'll have an effect. What do you see as some of the looking forward at the frontier of the research that you're doing and other climate scientists are doing, what are the next big issues? What are the things that, the problems, if you will, in the science that keep you, that get you excited and that are, what's on the frontier of the work at this point?
I think the integration, again, of the physical science and the social sciences is one that I find exciting. And one way in which that can enter into climate modeling, which a lot of our work involves, is through the integration of human factors into a model. That's obviously difficult to do. You can't put a number of people in there and try to simulate their decisions, but you can introduce the human decision element in a broad sense by having the humans interact with changes that are ongoing in the physical system, or humans can respond to changes that are going on in the physical system, so that you get a new dynamic. It's the dynamic between the human decisions and what actually happens in the physical system. And the ability to simulate those interactions, to me, is one of the real grand challenges. And it does require a lot more than physical scientists to work on a problem like that one. In fact, you could make the case that we have our work cut out for us as it is in trying to incorporate ecosystems into the picture. Right now, quite a few Earth system models do combine the climate component and at least some treatment of ecosystems, but that's still a step short of the human dimension and actually putting the human into the system that you're trying to simulate. It may well be that the next generation is the one that tackles that problem and makes some real advances. But I think we're just at the threshold now where we can start to bring humans and other complexities into these simulations and perhaps learn more than we would by just working in separate disciplines.
Yeah. It's really interesting to hear you say that, John. I have been heavily influenced in my own thinking by the work of Daniel Kahneman, who's a psychologist who won a Nobel in economics. I think he's the only psychologist ever to win a Nobel Prize, but he a great path-breaking work called Thinking, Fast and Slow. And he designed psychological experiments that helped us understand more about decision-making at a very practical level that our economic theory wasn't able to explain. And so there might be some interesting insights from his work. His thinking about thinking fast and slow, the limbic brain works very quickly, and it unfortunately our neocortex is the brain that thinks slowly and systematically and deeply about things, but often it's not as well trained perhaps as it ought to be. And sometimes it's tired or hungry or lazy. And that limbic brain sort of takes over because it's so powerful and so strong. And I think in this world of climate particularly, our thinking about it generally across society is really driven by that limbic brain, perhaps on both sides of the issue. And we need more of the kind of thinking that you're doing, which is that very deliberate, systematic, empirical kind of work, using that slow but powerful brain.
You know, that's an interesting notion that the brain at the individual level has these dependencies, because, I mean, ultimately it is individual decisions that shape the course of a society and ultimately the climate trajectory. But the challenge is to build upon, somehow integrate individual decisions into aggregate decisions that can actually impact a more complete physical system, a larger scale system. So I see that there are various levels that need to be taken into account before we really come up with what we would call a sort of a complete system that has the human dimension incorporated or embedded in it.
So are you, in addition to all the tremendous research that you're doing, is there also an educational component to your work?
Well, there is an outreach component.
Okay, great.
IARC does have an education and outreach group, and we do interact with them quite a bit. They're involved in our adaptation planning. We actually host visitors from school groups that come in, especially during the warm season. We have summer camps. Elena Sparrow has hosted these. We get visitors from the communities. Groups come in from the communities. And we do host workshops as well.
Great.
And we also get visitors from overseas. Lately we've been getting some tour groups from places like China and Japan coming through. So we do see quite a mix. And I'd say the level is quite different, obviously, between a K-12 group and a group of visitors from a foreign country. The way we have to target the message does change. So we can't simply have one canned presentation that we're giving to these groups. And at IARC, we also are hosting research experiences for undergraduates now. That's fairly new, but we bring in a group of undergraduate students from around the country each summer and immerse them in research projects. So we have a much stronger, what I consider a much stronger educational and outreach component than we did 10 years ago.
Oh, that's great to hear. You know, you mentioned visitors to IARC from China and Japan, for example. And I wanted to ask you about the extent of collaboration with researchers from the Arctic or from other Arctic nations or around the world. It is, after all, the International Arctic Research Center. So what sort of, what level and what's the nature of the collaboration internationally?
The nature is quite strong. In fact, that was one of the things that attracted me here. The UAF is, in some ways, it's a gateway to the Arctic. People come here and they're at least very close to the problems, the system components they're working on. But we do have collaborations very actively with a number of countries. We have a partnership with Russians that enables us to go on cruises into Russian waters in alternate years. And we've learned a lot about what's happening below the surface in the Arctic Ocean, underneath the sea ice, as it fades away. We've learned a lot from those cruises, which have been going on for about 15 years. And we've hosted a number of other Russian visitors over the years. We have very strong ties with Japan. In fact, Japan was a major contributor to our building back in the early 2000s. We work with the Japanese Marine Science Technology Corporation, the Japanese Space Agency. They actually run a major, what they call super site. It's a field site out at Poker Flat that makes measurements up to, they have a tower that goes up to about, I think, close to 100 meters. It's one of the largest towers in Alaska. And more recently, we've been getting visitors from China. So I'd say those collaborations are more in their evolving phase. We've had several trips over there. Several of their groups have visited here, but we are starting to develop some collaborations now with the Japanese. Japanese are particularly interested in establishing a site out on the Seward Peninsula, which we would do jointly with them since we have some ongoing work out there already. We've also collaborated quite actively with Germans and with Norwegians over the past 10, 15 years. So we do have, I'd say at any given time, maybe a third of our scientists are international. That's a third of the core scientists, and that's before we even get to these visiting groups and the collaborative projects. So I'd say the international collaboration is central to what we're doing.
Excellent. What gives you hope as you look forward, John? You're a distinguished researcher, and you've committed your entire career to discovery and sharing the fruit of your work and your knowledge. What gives you hope looking forward? You've taken on a big elephant here. Looking forward, what keeps you going?
I think the realization or the demonstration that people who know the most about science are the most perceptive about what the problems are and what the optimum solutions are, what the most prudent solutions are. So the challenge is to increase the information base or the information level among the general public. I think that there's a long way to go. As I mentioned earlier, that the public is misinformed on a number of just basic facts about the Arctic and climate change. That means that the gap between the floor and the ceiling is pretty high. So we have a lot of potential for making a difference. And I think if we can improve just the knowledge base of enough of the public, there will be a bottoms-up movement that we're already seeing to some extent in this country. I think that change is going to happen in this country eventually, but it's not going to be top-down. It's going to build up from the communities, the cities, and even the state level before it gets to the federal level. So I think if we start with our home base here in Alaska, use that as a sort of a springboard, I think we can start chipping away at what needs to be done in creating a more informed society that can make more rational and more prudent decisions that will certainly benefit future generations.
Great. You know, as I struggle with the issue of education in Alaska, I think about information a lot, and so I bring a lot of data to bear on my arguments for increased support for higher education in our state. One of the things I'm learning as I go through this is that data goes so far, and that really narrative storytelling is also a very, very powerful tool. So I think that's something that we need to try to get into the mix. And I totally admire your scientific work and your openness to working with scientists from other disciplines, economists, social scientists, etc. We might need to get the English folks in too, I think, and talk about creating stories that really deeply connect with people.
I think that there's a lot to be said for that.
Okay, great. Well, John, thank you. It's really an honor to be able to work with you and to have this conversation this morning. It's on a critically important topic for Alaska, for all of the people who live here, for our students, our university, but particularly for the world. And I admire your courage in taking on a critical issue like this and bringing to this issue your disciplined thought and scientific approach. It's really important contribution to how we make decisions about this critical issue. So thank you.
Well, thank you. And we appreciate the opportunity to work in this setting too. So there's a mutual expression of gratitude here.
Okay, very good, John. Thank you.